All right, we're moving on today here. Yesterday was finding the dimensions of plane figures. And today we will be finding dimensions of prisms. I see, said the one. All right, do we know what a prism is? Anybody have any ideas? Grayson? Okay, well, we'll start there. It is a 3D shape. Okay. Anything else? Prism. You not worked with these before? No? Okay. Okay, you have a rectangular prism. What makes it a prism is that you have 6 sides. Oh, here we go again.
No wonder when you have that no wonder
All right. Little malfunction there. You have 6 sides. That are rectangular. Okay, and here's where you got to know your properties of your two-dimensional shapes. Is a square a rectangle? Yes, it is. Yes, it is. Okay, what makes it, in this case, a rectangular prism are the ends are rectangular and they are parallel to one another. Okay, so I hope you're hearing that. What makes us a rectangular prism is that the ends, I don't know, you're right and left ends, are rectangular and they are parallel. Very important that they are parallel from one another. Okay, pretty good so far. Yeah? All right, let's talk about what goes inside of it. I don't want to give it away, but what do we call the space inside? Gulp? Nope. Okay, Han? That would be called volume. The amount of space that it occupies. How do we measure items that are three-dimensional? We measure them in cubic units. Okay, so we have a three-dimensional figure. In this case, we have a rectangular prism. What makes it a prism are the parallel rectangular sides. Everything is not a rectangular prism, and you're going to find that out mostly tomorrow. Volume is the amount of space that the object takes up. Okay, mainly when we talk about volume, it's about the inside of an object. Okay, but the space of the object itself. Okay, it could be a solid, that's fine. And then we measure this in cubic units, right? Remember we talked about the little 2 and the little 3 and all that? Remember that? Well, this would have a little 3 up there because we're talking about cubic units. So far, so good? All right, if we're talking about volume, I want to do that. If we're talking about volume, what is our formula for volume? Okay. The length of something, the width, and the height. That's correct. Do you need all 3 of those? Yes, you do, right? And those being side by side, I'm just putting in some reminders there, but those the raised dots usually aren't there. Those 3 numbers are multiplied together. Okay. If we were talking about area of something, that would just be the length and the width. Do you notice the difference of what makes it 3-dimensional? That is correct. The height is what makes it 3-dimensional. So if you have height to something, more than likely it's a 3-dimensional object. Okay, if you just have length and width, it's probably flat and it's probably a 2-dimensional figure. Okay, another word for height that they use would be depth. That is correct. Okay, height or the depth of something. Okay, usually those words, those vocabulary are talking about the volume. All right, we good so far? All right. All right, so let's take a look at these items. So here are some figures, bless you, that are broken down by cubes. And sometimes from these questions here, there's so many possibilities that they can ask you. Bless you. One of them might be, how many cubes are there in the pink figure? Now, with that being said, can you count all of the pink cubes? You cannot. You can't see them all. Okay, and we don't want you to guess. Math is not about guessing here. Okay, so Kahan told us that volume was equal to length times width times height. So we got 1, 2, 3, 4, 5 blocks there. That would be the length. 1, 2, 3, that would be the width. 1, 2 would be the height. Right, this is where you got to know the formula for volume, right? That's going to tell you. So what do we got there? 15, right? 15 times 2, we got 30 cubes. What happens if I would mix up the numbers? What happens if I would forget that it's length times width times height? Do I still get the same answer? Why is that? Brady? The commutative property, right? It's multiplication. Right? You can mix up all the numbers and still come up with the same answer. Okay, for the blue one, we got 1, 2, 3, right? Again, finding the volume. How many cubes are there, right? So 3 times 1, 2, 3 times 1, times 1, 2, 3. Okay, some of you will put 9. That's not good. Our answer is, what is it? 27 cubes. Okay, you're okay with the cube thing, right? Pretty simple stuff, right? Especially when they give you a visual like that, right? You can count across, count over, and count up. You're in good shape. All right, you're good with that. All right, let's take a look at this. I know some of you had that today for breakfast. All right. So generally, they will give you a picture. Sometimes they will give you a picture. Sometimes they will give you words. You'll see here in a minute. But we're finding how much goes into the box. Okay, so that would be length times width times height. I'm putting the dots in there now just so that you can see that, but the dots usually are not there, the raised dot. Okay, so the length here would be 8, the width is 3, and we don't know what the height is. Okay, they gave you the formula up here, so we're starting easy. And they're giving you what the volume is. Okay, the volume is 264 or whatever, inches squared, I guess, because they're giving you inches. Okay, so they came up with 264, and we already know that, we already know how to get 24x, right? We've been doing that. What kind of an equation do we have? Okay, hon, multiplication. So we're going to divide by 24, right? There's nothing on here that's new other than the picture, and it's three-dimensional. So instead of being a two-dimensional figure, it's a three-dimensional figure, and we're finding out what it is. Okay, because we want to find out what the length or the height is, I should say, of our cereal box. And when you divide that out, we arrive at 11 inches. Now, let's think about this for a minute. Your answer is 11 inches, yes? What dimension is that? Come on, we only got 3 of them, and we've talked about all of them extensively. Okay, hon? Well, what dimension is it? 1, 2, or 3? Nope. Cohen? Nope. It's one-dimensional. It's a line. Children, you're finding the height of something. That's one-dimensional. Do you see any 2 up here, or do you see any 3 up here? No. You're finding something that is one-dimensional. Look, length is one-dimensional. Width is one-dimensional. Height is one-dimensional. When you combine length and width, you now have something that's two-dimensional. We're not combining anything. We're finding the length or the height of the box. Does that make sense? I knew that this was going to be a small problem on what we're finding dimension-wise. They're giving you a three-dimensional object, but they're asking you to find something that's one-dimensional, the height of something. Understood? Okay. And then if we would add the height to it, now we are finding something that's three-dimensional. Okay, you got to understand these. So now we're dealing with 1s, 2s, and 3s today and tomorrow. All right, everybody go to that. Next one, dog treats. Again, we're finding, oh, don't worry, they're going to get harder here in a minute. Okay, they already gave you the formula, which is fine, but I want to plug these in just so that you see where they're coming from. Okay, and they already worked out the volume for you, the total, and you get 18x. Right, again, we have another multiplication equation. We divide, and again, we're finding the length, or the height, I guess, technically, of our dog treat box, which when you divide that out, it comes out to be 9 inches. That is a linear measurement, meaning it's a line. How do you go check it? Real simple, right? 4 5/10 times 4 times 9. Now, take a look at the check. Remember earlier, way earlier in the year, we talked about something that looked like this? We said not to use the X because it could be misconstrued. Remember that as a multiplication? Well, guess what? Now, all of those are now numbers. Right? Remember that? Now we're multiplying 3 numbers in a row. Now you better have parentheses around 2 of them. Don't use the raised dot, please. You're getting away from that a little bit. And obviously don't use the X, right? You're substituting in numbers now. Does it matter how you multiply these 3 together? No, the commutative property. Generally, people go left to right because that's how math works. It's just like reading a book. Everybody good so far? Everybody good? All right, do that one on your own. Write the equation. Right? If you're not sure what the volume formula is, you can use your cheat sheet. I'll write it up here for you. Okay? Write an equation, solve it, find the linear measurement. I'm not sure what we're typing on our computer there, but we should be working on our math problem. Are we good? Anybody ready? Anybody need more time? $72 is the total. That's the volume. We don't know the length. $72 is equal to 12L, yes? That's what you should have got there. After you combined like terms, multiplied together, divide by 12. What's the length of our box here? 6. Inches, don't forget the label. We're going to talk about labeling here in a minute. 6 inches. Do you need the label? Yes. Yes, you need the label. You need the label. Everybody good so far? Yes or no? All right. This is why you need the label. What if the question just said, find the volume? And they give you a picture. What are you going to do? Ready? Going to multiply all the numbers together. 6 times 8 times 3. 6 times 8 is 48. 48 times 3 is 144. Is that my answer? What do I do? Michael? What do I label? What's that? Yeah. You better have feet cubed, children. If they're talking about volume, if you just put feet, I told you what people are going to think. It's a straight line of 144 feet. We can't keep talking about our labels here. If you put 144 feet squared, automatically somebody's brain goes, okay, it's a two-dimensional figure. It's flat. It's 144 square inches. Now, if you label something 144 feet cubed, their brain goes to this object right there. 3 drastically different dimensions. You got to know them and you got to label correctly. Okay? Everybody good? Okay. All right, now we work to our word problems. I know it scares me too, but all right, once again, the one thing that I will tell you, especially when we're dealing with volume, is when you can draw a picture. Draw the picture. Do not try to do these in your head. Don't try to do them on the calculator. Draw a picture. We think in pictures. Your picture does not have to be fantastic. Okay? The office cubicle measures 7 feet by 8 feet by 5 feet. What is the volume of the cube? Okay? Yeah, I know, Mr. Fisher, but you told me that the volume is just 7 times 8. All you got to do is multiply them together. I know that. But you're going to see here in a minute, you need to draw a picture. Okay, 7 times 8 is 56 times 5. That gives us 280 feet cubed. I'll do the math for you. You got to get this down right here. Let's be honest, the math is easy, isn't it? I mean, the math isn't hard. It goes back to chapter 1, 1.3, lesson 1.3, chapter 1, right? The commutative property. Just multiply them all together. Bless you. All right, now it gets a little bit increasingly more difficult. A cube with side lengths 4 centimeters. Okay, now, what does a cube mean? Verbalize a cube. Okay, all sides are the same. And again, your picture does not have to be, I'm not asking you to be an artist. That means everything is 4 by 4. Everything. Every length is 4. Okay? That's what a cube says. So it says a side length of 4 is 25% full of sand. What is the volume of the sand? Interesting. Let's draw some sand. It's about 25% full. Okay, how do we go about doing this? Any suggestions? What do you need to find first? Go ahead. I didn't hear you, buddy. Okay, correct. First thing is you want to find the volume. So what's our volume? 4 times 4 times 4. That would be 16 times 4. That would be 64. And we're talking centimeters squared. But it says 25% of it, going back to chapter 4 now, 25% of it is full of sand. How do we find how much sand's in there? Zach, what do we do? Say it again. Okay, we could do that. We could divide by 4. What's 64 divided by 4? 16. So we get 16 cubic centimeters. What else could we do to 64? Brady? Multiply it by 25 hundredths. I like that. Very good. You get 16. What else could we do? It's another option. Go. Times it by a fourth. That is correct, sir. Right? So you have many options here of doing the same problem. So you have 16 cubic centimeters of sand. That's the volume of the sand in that cube. Okay? So far, so good. Oh boy. A cube has sides of length of 2 meters. Explain what happens to the volume of the cube if the length of the sides is doubled. I would let you do this on your own, but we'd be here a while. Listen, this is where you have to draw pictures because the visual is going to give you the answer. Do not try these in your head. So we're going to have a cube, right? It said the length was 2 meters, yes? So what is the volume of this object? Michael? 8 meters cubed. That's correct. Okay, so just by looking at that visual, if we double the length of the sides, what's your answer? Michael? Okay, anybody else? If we doubled the length, which we just did this problem earlier, oops, we're talking meters, aren't we? Meters cubed. Okay, now, guess what? We're not done with the problem yet. Because the question says, explain what happens to the volume. So in other words, what happened from here to there? What happened? Kahan? No. Did the volume double? No. Now, I'm glad you said that because guess what? 99% of the children, that's what they say. Well, the sides doubled. That means the volume's doubled. No. This is where you need the visual. What is the difference from there to there? Michael. Yeah, but we need to explain what happens to the volume. How many times larger did the volume get? That's what they're asking you. Zach. No. Oh, Chen knows. The volume got 8 times bigger. What's 8 times 8? There's your increase in size. Got 8 times larger just by doubling the length of the sides. Did your head stop spinning yet? Well, we didn't do too well on that. 8 times larger. Pictures help. Finding the volume. What is, and you got to answer the problem. Explain what happens to the volume. What happens to the volume? It gets 8 times bigger. All right. Everybody good? Hello. All right. All right. In the book here, we got lesson 7-6. Now, be careful. There's a 7-6B. We're not doing B. We're doing 7-6. We're going to do 1 through 15, the odds. And you have another record and practice paper in there. Okay, you need to do all of those.